Welcome guys to another video. Today we have a lesson on chemistry and the topic for today is salt preparation, which is chapter 17 of the chemistry course. And salt preparation is a very common question that can appear on both paper 1 and paper 2. So let's take a look. The first thing that you need to know when it comes to salt preparation are your solubility rules. And the specification has provided us with a very detailed list of all the solubility rules that you need to know at this level. But I think it's very complicated, and when it comes to memorization, this 6 bullet point list looks overwhelming and it just looks all over the place. So I want to take this opportunity to teach you a learning technique or a study technique that will help you memorize strategically. And I like to call it grouping. And it's basically what the name suggests. Grouping means you're looking for patterns, similarities, and connections in different pieces of information, and you are forming groups or chunks of information based on those connections and similarities. So what we're going to do is we are going to carefully study this list, and we're going to convert that into groups and into something that is more memorable and easier to tackle and easier to learn. And we're going to be using a table to memorize our solubility rules. We have 3 columns: ions, soluble, and insoluble. And under the ions column, we're going to put 4 named ions. And the way that you're going to remember these ions is with the shorthand A, night, sol, height. Okay, and at least that's how I like to remember it. So A stands for ammonium and alkali metal ions. So you have sodium, lithium, potassium ions. Night stands for nitrates, sol stands for sulfates, height stands for halides. So things like fluorides, bromides, and iodides fall under the category of halides. And as for whether they are soluble or insoluble, for now we're just going to put all in these 4 named ions, which means that all of them are soluble. However, there are exceptions, and these exceptions apply to sulfates and halides. Okay, now how do we remember to which ions these exceptions apply? Well, we're going to use our fingers. Your thumb represents your ammonium and alkali metal ions, so this is going to be your A. This finger is going to represent the A part of the ions. And your index finger is going to represent your nitrates. Your middle finger is going to represent your sulfates, and your ring finger is representing your halides, and the pinky finger is representing the other ions category. So you've got these 5 fingers representing these different ions. And when you make this kind of rock and roll shape, I don't know how to call it, and the 2 fingers that are folded are going to be the ones to which the exceptions applied. And these fingers happen to represent your sulfates and your halides. Okay, so that's how I like to remember where the exceptions apply. Okay, now what about the scenarios in which these exceptions apply? Well, these exceptions of being insoluble are going to apply when the sulfates or halides are going to be paired with certain cations. And these cations are A, B, C, P for sulfates, and A and P for halides. And as you can see, there's this kind of pin shape, or an N, small n shape that's going on with these exceptions. So I like to use that as a visual cue to memorize the exceptions when it comes to sulfates and halides. And these letters are going to represent the chemical symbols of the cations. A represents Ag, which is silver. B represents barium, Ba. C represents Ca, calcium, and Pb represents lead. And the same goes for your halides. So what you need to remember is this visual cue, is this little pin shape or the small n shape. And you need to remember that they are going to be A, B, C, P for sulfates and AP for halides, and you just fill in them with the metallic elements, the metallic chemical symbol elements, and you will get to know the cations for which these insoluble exceptions apply. As for other ions, specifically other polyatomic anions, we are going to note that all of them are insoluble. So your carbonates and your hydroxides, they are going to be forming insoluble salts, unless they are paired with ammonium ions or your alkali metal ions. And that makes sense because this rule up here overrides that rule, which says that all ammonium ions and alkali metal ions are soluble. So it doesn't matter what the anion is, as long as there's an ammonium, as long as there's a sodium or a lithium or a potassium, all of them are going to be soluble. And the little exception, another extra exception that you need to know is calcium hydroxide. Now, calcium hydroxide is slightly soluble. I've never seen any past paper question that asks about the solubility of calcium hydroxide. It's just in the very bottom part of the specification. So I think it's a little detail that's worth noting, but it hasn't come up in any past year papers thus far. Yeah, anyway, this is going to be your table. And as you can see, it's very simple. 3 columns, a few words, this little shape, that visual cue. And that's going to really help you memorize without feeling overwhelmed, without feeling confused, without going through all of that complex text. And so take a look at where we started. We started with this long list, and we've converted that into a table that's going to make things a lot easier for us to memorize, because we've got patterns, we've got groups, and it's very simple and it's very straightforward. There's no complex wording. It's just very easy to memorize. I was taught by my chemistry teacher on how to memorize in this way. He's an absolute legend. So I hope you guys are as amazed by I am with this kind of technique. But this is not the only way to memorize solubility rules. You know, other people have different methods. They have different ways of grouping the different ions. And so the key lesson here isn't about this particular tabulation method, but it's about ensuring that you are grouping the different pieces of information and that you are memorizing in chunks rather than memorizing isolated pieces of information. And you need to make sure that what you're learning makes sense to you. So as for me, this kind of shape, that little pin shape, makes sense to me because I can see that shape, and I can also use the ABCPQs to help me remember what the cations are. And I'm also using my fingers to remember where the exceptions lie. It doesn't have to make sense to other people, it just needs to make sense to you. If it doesn't make sense to you, your brain won't remember it unless it is meaningful to you. Okay, so that's everything for the solubility rules. Let's now look at how we're going to be actually preparing the salts. And it really just comes down to whether the final salt that we want is soluble or insoluble. If it's a soluble salt that we are trying to create, we are going to be using the crystallization method of separation. If it's an insoluble salt, we are going to be using the precipitation method of separation. If you take a look at the specification, you will notice that the insoluble salt preparation is actually a paper 2 content. And therefore, it gives us the knowledge that if we have a salt preparation question on paper 1C, then we can be 100% sure that we are preparing a soluble salt, because insoluble salts can only come up on paper 2 for triple science students. And therefore, if it's a paper 1 question, we are 100% sure that we are doing the crystallization method. So that's a little cheat code. And if you are short on time when you're revising for paper 1, you can use this to prioritize and focus your revision only on soluble salts for paper 1. And as for the preparation of the salt compounds, it differs depending on the cation that is in your final soluble salt. If the cation is an ammonium or an alkali metal, we are going to be using the titration method. If it's any other type of cation, something like a magnesium or a copper ion that is in a final salt, we are going to be using the solid plus acid reaction. The solid could be the metal itself, and these metals could be your mesyl metals. Metal basically stands for magnesium, aluminium, zinc, iron, and lead. And these are the metals whose elemental forms, whose solids can directly react with an acid. Or if it's not a metal metal, you can react the oxide of the metal or the carbonate of the metal with an acid to get the soluble salt. When it comes to ammonium and alkali metal ion containing salts, we are going to, of course, have to do the titration first to figure out the exact volumes required for complete neutralization using an indicator. We'll then repeat the titration without an indicator, and we'll just mix those exact volumes together to obtain the salt solution, the pure salt solution, and this will give us the solution that we want. If it's any other type of cation in the final salt, we are going to be using the solid plus acid reaction, and what we're going to be doing is we are going to be adding an excess solid. So this solid could be the metal metal or the metal oxide or the metal carbonate to the acid, and the acid is going to be heated in order to speed up the reaction. Now once we have added an excess of the solid, we are going to filter it out so that in the filtrate we get a pure salt solution. And a common question is, why do you need to add an excess of salt? Well, that's because we need to make sure that all the acid in the beaker is neutralized. If we have leftover acid, that means that the solution that we obtain at the end isn't just the pure salt solution. It will also contain the leftover acid, and we don't want that because we want pure salt. But wherever we start with titration, or whether we mix the solid and the acid together, the next step of crystallization is going to be the same. So once we get the filtrate or the solution containing the salt, we are going to transfer that into an evaporating dish. And we're going to be heating that evaporating dish using a water bath so that some of the water in the salt solution evaporates. And we have to do this heating until salt crystals start forming. The way to test for this is to use a glass rod. We will dip a glass rod into the salt solution, and if crystals form on the tip of the glass rod, then we can say that crystallization has started. We are then going to take the evaporating dish and leave it somewhere to let it cool so that crystallization completes. Once crystallization has completed, we are transferring the mixture and pouring it through a filter paper contained in a filter funnel. And the liquid is going to run down the filter funnel into a conical flask, and we're going to be left with a residue of the salt crystals. What we need to do now is to let the salt crystals dry in a watch glass, and we can put it in a warm place, for example a warm oven, and we can wait some time, and then we will get the pure dry salt crystals that we want. And that's how we make soluble salt crystals. Okay, how do we describe this in exam scenarios? Well, when it comes to crystallization, there are 4 key steps: heating, cooling, filtering, and drying. And we just need to add some details to get the extra marks. So these details are things like heating gently in order to remove some water by evaporation, not all water. And we're going to be heating until crystals start forming, and we're going to be drying them in a warm oven. So basically the key points are heating, cooling, filtering, and drying, and then we follow them up with a few extra details to get full marks. Okay, now let's take a look at forming insoluble salts. Generally, when we are making insoluble salts, we take a solution and react it with another solution made of course, 2 different soluble compounds. And as a general rule of thumb, we like to use sodium-containing solutions and react them with nitrate-containing solutions. And that's because if you recall the solubility rules, all alkali metal ion-containing compounds are soluble and all nitric compounds are soluble. And therefore, it doesn't matter what the anion is in the sodium solution. It doesn't matter what the cation is in the nitrate solution. We are always going to have soluble compounds, and therefore we are always going to have solutions And so we can always mix them together to form an insoluble salt. And of course, the anion here and the cation here will vary depending on what the final compound that you want is. So the reason we can't use an insoluble reactant is because we are going to be taking out the insoluble salt, the final product, by filtration. And when we filter it out, we are going to have the insoluble salt product as the residue in the filter paper. If we had an insoluble reactant as well, the residue is going to consist of both the insoluble reactant as well as the final product that we want. And therefore, the final product will become contaminated by the insoluble reactant. And that is not giving us the pure salt we want. And therefore, we only use soluble reactants. Okay, so we mix these two solutions together. And when we mix them together and they react, we are going to get the precipitate of the solid salt that we want, and it's going to form. What we're going to do is we are going to pour that mixture of the solid salt and the other product through a filter funnel, filter paper, and we are going to obtain the solid as the residue, and the rest of the liquid will trickle down as the filtrate. And what we can do with that residue is we can wash it with water, and after washing we can leave it to dry in a warm oven, and that will complete our procedure. So here are the key points that you need to write in your exam. Mix, filter, wash, and dry. Simple as that. And the reason we need to wash the residue, the solid salts, is because when we pour them out through the filter funnel, some of the liquid, little bits of it, could remain on the outside of the solid. So we're washing it to remove any remaining solution on the solid in order to obtain a pure salt. And for those of you students who might be watching this that are Burmese, in your language, you can memorize it as Yo Sit Se Chap, which makes things a lot easier, a lot more concise, and a lot more straightforward. But in English, it's also still very simple and very short and succinct. Mix, filter, wash, dry, or in Burmese, Yo Sit Se Chap. Very simple. Alright, let's take a look at some past paper questions. We are starting with the question from 2023 November paper 1C. Now remember guys, if it's a question on salt preparation on paper 1, it has to be soluble salt that we are forming. And therefore, the method definitely has to be crystallization. But let's still take a look at the question. This is the method that we use to produce hydrated zinc nitrate crystals. Salt that we want, guys, is zinc nitrate. As you can see, it's a nitrate salt, and therefore it has to be soluble because all nitrates are soluble, and therefore it has to be crystallization. And as you can see, our prediction is indeed correct. We are mixing nitric acid with zinc powder, which is added in excess. We're then filtering it, and we then get zinc nitrate crystals. And part A asks why we need to filter the mixture. And that's simple. We need to filter it out because we have an excess of zinc. There is some leftover zinc that hasn't reacted with the acid. And so because we want the salt solution, we need to take out the unreacted excess zinc solid. And that is going to be the answer for part A. Now part B is the preparation question. It says describe how a pure, dry sample of hydrated zinc nitrate crystals could be obtained from the filtrate. So what you need to do in these kind of salt preparation questions is to determine your starting point. So in this particular question, guys, our starting point is going to be the filtrate, and the filtrate is going to be the zinc nitrate solution. So we just need to take crystals out of the solution. So what do? We heat, we cool, we filter, and then we dry. And then we add some details, and that should be the complete response. And here is the mark scheme. It is very similar. It's a very similar set of mark points every single year, and the key points are always heating, cooling, filtering, and drying. And some years they want these details, sometimes they don't, but it's always good to add these details for completeness and to make sure that you're always banking full marks regardless of the changes to the mark scheme. Alright, next question from 2023 June, paper 2 CR. And because it's the paper 2 question, they can ask you about insoluble salts. In this case, we are doing lead 2 bromide. Now recall your solubility rules, guys. Bromide is a halide, and halide has two exceptions. What are the exceptions? These exceptions are that if they are paired with silver ions or lead-2 ions, you are going to get insoluble salts. And indeed, because a halide is paired with a lead-2 ion, we have an insoluble salt. And we are going to be using a precipitation reaction to make the salt. The question asks how we can make how we can use lead nitrate and potassium bromide to make a pure dry sample of lead-2 bromide. Now, in this question, guys, what is the starting point? The starting point in this question, guys, are going to be our reactants, our two soluble solutions. So what do we do with those solutions? We mix them together, we react them, and that will form the precipitate, the solid salt. We will then filter it out, we'll then wash it to remove any excess solution, and then we will be drying it in a warm place, and then we will get our pure dry sample. So here is going to be our response. Remember the key points, guys: mix, filter, wash, dry. Your sit, say, chow in Burmese. And this is the mark scheme. The key points, guys: mix, filter, wash, dry. And of course, mark point 4 asks you the detail of drying. So you can't just say dry. You'll have to say leave to dry in a warm oven, in a warm place, etc. So dry, the word on its own is not enough. So you need to give some details if you want to bank 4 marks, which is why I suggest writing the details even if the mark scheme doesn't include that, because being complete makes sure that you will always bank 4 marks even if the mark scheme goes on to demand the details. And guys, this is the summary of today's lesson. This is all you need to know for your solubility rules. This is the table, absolutely OP way of remembering the solubility rules for Edexcel International GCSE at least. And this is going to be the summary of the salt preparation methods. Guys, with this single slide, you are going to start banking 4 to 5 marks on paper 1 and maybe 4 marks on paper 2 as well. So this is a very important slide. And of course, precipitation, the insoluble salt separation method, comes only on paper 2. But yeah, that's everything for today's lesson. Thank you all for watching until the end. I hope you've learned about salt preparation, a very important and common type of question. And I've also hoped that you've learned how to study more effectively using the grouping method. And I strongly encourage you guys to use it in other subjects as well. And please let me know how you're using that, and if you find any success with it. Good luck with all of your examinations, and I'll see you guys in the next video. Peace.